Hi, today I want us to explore the buffer function in Google Earth Engine and how we can use it to generate our area of interest instead of uploading the shapefile to define our area of study. So we're going to explore the buffer function where we can pass in the distance in meters, and then we can use to create the area of interest in any location that we would like to perform our study. So for that case, I would like us to head over to the documentation here in Google Earth Engine, and then we are going to filter the methods. So here we can type in buffer, and if you search buffer, since we are going to use the point, but there are different methods here that you can read through. But for our case, we are going to use the point. So here under the ee.geometry.point, you can see we have the buffer takes in 3 arguments. So the distance, the max error, and the projection. And here you can see it says that it returns the input buffered by a given distance. So if you pass in distance, for example 100, so the default is in meters. Unless you define the projection, then you will go ahead to change the units in for distance. So if the distance is positive, the geometry is expanded, and if the distance is negative, the geometry is contracted. Okay, then under arguments you can see we have the geometry, so it must be ee.geometry then point, and for that case inside the buffer function we have the distance, and it can be a floating a point or a whole number. And then you can see it says the distance, just as we have read. If no projection is specified, the unit is in meters. Yeah, I think I've mentioned that. So if you don't pass the projection, let's say you say buffer, then inside you just say something like 100 meters, that means it is in meters. If you specify the projection, then you will change the most probably you have to change the units. Okay, then otherwise the units will take the coordinate system, so the projection. Then we have the max error. It's an error margin, by default is null, so the maximum amount of error tolerated when approximating the buffering circle and performing any necessary reprojection. If unspecified, defaults to 1% of the distance. So for our case, we are only going to pass in the distance, which will be something like 100 or 200 meters. Then the rest of the arguments we shall not do that. Okay, so I think this the documentation here is very helpful. You can go through it and try to learn more about how to use the buffer, how to apply the buffer method. Okay, so here for our case we're going to use the sentinel. So here you can type in sentinel2, then we wait for, I think we can just type in sentinel, then we can select this one, the sentinel2 MSI, that's multispectral instrument. Then you can go ahead and copy this link or the code snippet to our image collection. So I can copy that, then I close. I'm using dark mode. So for that case, we can say a variable sentinel2 is equal to ee.image collection. So I can just paste that. Okay, so then if I hover over this, it says sentinel2 can be converted to an import record. So you can convert to that or ignore. So I'm just going to ignore for now. Then I go ahead and define my area of interest. So I can say the region of interest is ROI is equal to ee.geometry.point, as I said. So this is the point, and this one takes in a single point for our location where we are going to buffer. For example, if it is in the United States, you just pick a single coordinate, then you will buffer that for your area of study. Yeah, so it will expand if it is positive, and then contracts if it is a negative value. Okay, so for that case, I'm going to copy here. You can type in any area that you want. Then for that case, I say buffer like that. Then I'm going to buffer for 2000 meters. This is like 2 kilometers. Okay, then I go ahead and then say I can filter out the atmospheric, or make the atmospheric corrections for this. So I try to filter out some of the characteristics so that we can remain with an image that is really reasonable for us. Then so for that case, I can filter out the collection for specific date, range, and also the region of interest. Okay, so I say variable my image. I'll just name the variable as my image, and then I say sentinel 2. Sentinel 2. So make sure this one resembles whatever we are using here, because this is the image collection. Then we can say dot filter filter date, and then we can pass in the dates. So for example, I can say 2023 January date 1st to something like 2023 December 31st. So this is the date. Then we can also filter out I can say dot filter filter bounds, then we pass in our ROI, which is the buffered region. So if for now we only have the point, I've said if you remove the buffer, that means we don't have the area, we only have the single point. But buffering allows us to expand the area of interest up to 2 kilometers. So this is 2000 meters by default. You remember, as we have read just here in the documentation, it says by default is in meters. If you pass in the projection, then you will have to define whatever the units that come with the projection. Okay, then we can also say dot first. So we just want to pass in, or we have to use the first image from the image collection. Okay, then we can print this image and see its characteristics. So I can say print and print my underscore image like this. So to save, you click on save like this, and then you run, click on run. So this is going to print out the image on the console, and you can see we have filtered out some bands. Then now we are remaining with 26 elements, and here we have the first band, the second, third, and so forth. Okay, we are not interested in those, but you can perform something like NDVI, yeah. But then before that, we need to center this object. So we can say map.set center, and then we pass in the same coordinates like this. Oops. So you copy this, then you paste inside the map.center method like that. So the next thing is to add the image to the map. So we can say map.add layer, and then you pass in your image. You say my image like this, and then you can clip also. You can say dot clip, then the clip is a function, so you are clipping out the area of interest, so the region of study. And then this one is for visualization parameters. For now we are going to leave it as empty because we don't want to define the parameters now. Then you can just say this is sentinel, so this is the name of the layer that will appear here. Okay, so you click on save, and then you run for that case. Yeah, so we are somewhere here, but we are not zooming into the area of of study. So here I forgot to pass in the zoom level as 13. Control save, and then you can run. Okay, so this is how it looks like. So this is our buffer, 2 kilometers from the center point. So these are radius of 2 kilometers, that's 2000 meters. Okay, I think we can perform a simple function like NDVI to just show you how this one works. Yes, just like any area of study, so you can use it to perform whatever the studies you want to make. Okay, so for that case, we'll define a function. For example, var get underscore NDVI is equal to a function, and this function is going to take an image as an argument, because we want to get the NDVI and we want to use that image dot. Now we pass in the normalized function from Google Earth Engine. So we say image dot normalized different. I think it's supposed to be difference. Normalized difference. Normalized difference like this. So this is Sentinel, and to calculate NDVI we need the near infrared and the red band, and for Sentinel is band 4 is red and band 5 is near infrared. So we're going to select those bands, band 5 and band 4, right? Okay, then we are going to rename. So we are going to rename this as NDVI like this. For that case, then for that we need to return our NDVI. So return NDVI, so the value that we have just defined above. Okay, so for this function is doing or performing the calculation to get the NDVI, so the normalized difference, and then we pass in the bands that are used to get the NDVI, normalized difference vegetation index. So band 5, which is near infrared, and band 4, which is red. Okay, so remember that we only used a single image here where we said first. So we pass in the first image. We want to map through all the images. Okay, so here we can say var final, you can say final underscore NDVI is equal to, we get the NDVI, so the function that we just defined above, which is doing all the work. Then we pass in the image, so my image like this. So this is the image collection, but we are just using the single image from the image collection, so we need the whole image collection. Then we say dot clip, then we clip by the area of interest. Okay, for now we are not going to do this, but I will show you later in a different video where we shall be importing this to Drive. Then we can do the rest of classification maybe in another software like QGIS or ArcMap. So for now, I'll just do it like this. Then we can go ahead and add to layer. So map.add layer. Then we are adding the final NDVI, right? So this, Control C, final NDVI dot clip like this. Then we pass in the ROI, and then we define the visualization parameters, for example, and then the name of the variable, that's n, or the name of the layer, that is NDVI. Okay, one thing I forgot is the palette. Since this is an NDVI and we would like to visualize how it looks like here on this image of ours, so I'm just going to copy these colors here, and I'll just explain it as we proceed. So I'm going to paste the palettes there like so. So we have these colors from, this is red. If you want to know what colors these hex codes represent, you can just copy these and then head over to color picker, then you can paste in here. If you paste the hex code, it will convert it to a color that you like to see. So for our case, this is red. Then from red we are going to this, I think it is orange, and so on until we reach to the green one. So dark green, this is green, this is dark green. If I can just copy this to be certain and then paste, you can see this is green. Okay, so places where we shall have red will show that we have less NDVI or less vegetation. Those that will have green color will indicate that we have a lot of vegetation, or the index is high. Also, I have this link from the USGS that you can learn. You can read through some of the information here. You can see here it says that the NDVI values range from +1 to -1, and then areas of barren rock, sand, or snow usually show very low NDVI values, for example 0.1 or less. Sparse vegetation such as shrubs and grasslands or senescing crops may result in moderate NDVI values, approximately 0.2 to around 0.5. Then the high NDVI values, approximately 0.6 to 0.9 or even 1, correspond to a dense vegetation such as that found in temperate and tropical forests. Okay, so I will leave this link in the description so that you can go through this and get to know more about NDVI. Okay, so here, instead of just an empty object like this, we are going to pass in the minimum and maximum value. So remember, we've said that NDVI begins from minimum value of -1 to the maximum value of +1. Okay, then we can pass in the palette. The palette is going to be the palette that we have here, this one. So palette is the palette. Control save and then run. So I can expand this. So you can see we have two layers. The first one is the NDVI and the other one is the image itself, so the sentinel image here. Okay, so we can uncheck the raw image, and then here on the NDVI you click on this icon. Then you can see here we have the NDVI. You click on this arrow that says custom, then you stretch to either 100 or 98%. So I'm going to use 100%. Then I click on apply, then close. So you can see here we've got our NDVI, and the places we have red or orange shows that we have less vegetation, and those that are green patches means that we have at least quite high NDVI value. If you want to know that, you click on inspect, then you can zoom in a bit. You click here on this pixel and scroll down here on the inspect, and here you can see it says that it's 0.09. Then if you click on this, the NDVI is 0.03. If we can look for a much denser one, for example this one here, that one should be higher. Okay, so it is still 0.09. The red one 0.02. So you can see how it is varying from different color to different color depending on how we have defined our palette here. Okay, so the ones for green shows that we have quite high NDVI, or the vegetation index. That means that we have some kind of vegetation here, but for those which are too much red or orange, shows that we have less NDVI. Okay, so this is basically, I wanted to show you how to use the buffer function, which you can use to define the area of study. So if you just want to get a quicker NDVI, or any method that you like to get, any study, for example NDVI or survey, you can use the buffer if you don't want to go to the whole process of uploading the shapefile or maybe drawing the area of interest on the map. Yeah, so I hope this was helpful. Thank you for watching. In the next one, I'll show you how we can import this or export this to Drive. Then later on, I'll do some visualization in the GIS software. Okay, thank you, and I'll see you in the next one.